Good afternoon and welcome to the Computer Security Seminar from Purdue University. Our speaker today is Rafae Bhatti. He's a PhD student from the School of Electrical and Computer Engineering. His faculty advisors are Arifka Four and Elisa Bertino. He'll be graduating with his PhD this spring, and his topic is what he'll be covering today with us, xFederate, a policy engineering framework for federated access management. Rafae?
Thank you, Randy. Well, good afternoon, everyone. I'm pleased and honored to present the CERIAS Security Seminar today. The topic, xFederate, a policy engineering framework for federated access management. So, let's get started. Here's an outline. I'm briefly going to introduce the problem. What is the federated access management challenge? Why is policy-based system an appropriate mechanism to address that challenge, and what are the shortcomings of existing policy-based approaches? This will lead us to policy engineering framework, which is my primary research contribution for my PhD dissertation. It comprises of a language specification and a UML-based meta model. I will then discuss a federation architecture that realizes this framework. Toward the end of the talk, we will have an application that discusses an example of a healthcare federation. So we have used our policy engineering framework and applied the methodology toward a healthcare federation example. And if I can connect to the internet, I'll probably have time for a prototype demo. And we will then conclude and take any questions you may have. Okay, so what is the information integration challenge? This picture here gives the high-level overview of the problem. This could represent, among other things, your national cybersecurity infrastructure. And these domains are a series of interconnected domains which are, this interconnection is enabled using collaborative architecture such as grid or peer-to-peer systems. And at the heart of this infrastructure is the federated databases. Federated databases are heterogeneous information sources, and they are characterized by distributed, potentially mutually untrusted domains. And the problem that I'm going to address here is security in federated systems. So at this point, you might ask that, isn't it just a network of databases? And if so, isn't network security enough? Or for that matter, isn't database security enough? And if the answer to that question was yes, then I wouldn't have worked on the problem at all, right? So I'll take some advice from history to answer that problem. SQL Slammer and Code Red were the two of most deadliest worms in computer history. And those worms brought home a message. They attacked a weak point in many companies' systems, the database, and showed how interconnected databases can provide security vulnerabilities. Most of you would be aware of security vulnerabilities that are exploited through malicious code. Intrusion attacks are used to inject malicious code. However, these vulnerabilities are not only exploited through malicious code, but also through legitimate but unacceptable accesses. The link right here on the slide gives a very good idea about such legitimate unacceptable accesses that occur to the personal information of every one of us, stored in interconnected databases of online retailers, mortgagers, insurance providers, etc. Why? Because of inadequate access control policies. I was going through this recent March issue of Communication of ACM magazine, and it always has a security watch or an inside risks column on the last page. And this month, the title is Real ID, Real Trouble. And I thought it would be interesting to discuss that because it talks about setting up a real ID based on the Real ID Act of 2005, a federated information system which would involve the use of a federally approved ID card to travel on an airplane, open a bank account, collect Social Security payments, and take advantage of nearly any government service. And some noted security experts have pointed out some security risks, including, quote, the biggest risk of a national ID system is the database. Any national ID card assumes the existence of a national database, and large databases always have errors and outdated information. So imagine, as shown on the slide, 500,000 interconnected databases. So we don't really have to wait for intrusion attacks or malicious code for a security breach to occur. It's potentially occurring every day. We need access control management. All right. So I've talked about the motivation behind access control management and why it would be needed in federated systems, highly interconnected database systems. Let's talk about some of the key access control policy challenges. And why are these systems much more difficult to manage than traditional systems? So the key principle in federated systems is autonomy. Each domain maintains autonomy to its information sources. And by that I mean that each domain has the right to exercise its own access control policy. For example, domain B might say that a user John has access to a level 2 resource, whereas domain A might say that the same user has access to a level 1 resource. How do you match the two? This leads us to the problem of decentralized administration. Each domain enforces its own access control policy, and so the problem is that who is going to control the policy in the federated system? Attribute-based access control. Suppose domain D has a policy for user John and also domain E has a policy for user John. But the question now is, should that policy be based on the ID of the user or some attributes that the user has? If the policy is based on the ID, then domain D does not necessarily know about the ID of every single John in domain E. Remember, they are distributed and untrusted domains. So they wouldn't know in advance about the IDs of every single user in other domains. On the other hand, if the policy is based on attributes, then they can potentially serve all the users who satisfy that attribute. Leading from the previous argument, we have another problem. Even if you assume that domain D knows the ID of every other John in every other domain, this leads to a rule explosion problem, because you would have to replicate the identity databases of one domain across all the other domains. Federation. Domain E might have a policy for user John to access a level 1 resource in domain D. However, the challenge here is that for John to be able to access that resource in domain D, you need interoperable protocols to be able to federate those credentials to the other domain. If you write your policy in a totally different format, then it wouldn't be understandable to the other domain. And last but not the least, constraints. Federated systems have a pronounced requirement for constraint specification because in an interconnected system, it is very important to give the access privileges only when absolutely necessary so that the exposure to the information is minimized. For example, many of us use online banking and other online systems, and most of the systems have all or nothing authorizations for your customers. You enter your username and password and you get access to everything that every other person in that every other customer gets. However, it's much more important in federated systems that the access is granted only when it is absolutely needed. For example, if a billing clerk in your financial institution has to issue you a monthly bill, they only get to work when your billing cycle completes. And a billing cycle typically ends at the end of the month or the beginning of the month. So it's only intuitive that the billing clerk should get access to your information only within the certain time frame that they have to work in. And so this leads us to the idea of constraints. So constraints can be of multiple types. You can have semantic constraints. What that means is that John may have access to level 1 and level 2 resources in domain A, but not at the same time. This is called separation of duty. Other kinds of constraints are temporal and non-temporal contextual constraints. For example, John may access level 1 resource in domain D, but only on Wednesdays and only from emergency ward. Okay. So these are 6 challenges that we have identified for access control policy design in federated systems. Let's see. You may be thinking that haven't other people already